Hello everyone and welcome back to my devlog. So some time ago I got interested in ASCII art and found a website that could take in pictures and produce ASCII equivalents. I could vaguely guess how it worked, but to truly understand I had to put it in code. So in this video I'll take you through a simplified process in about 4 minutes. But before we start, I urge you to leave a like and subscribe to the channel. Now let's jump right into ASCII pictures. Okay, so the first step in this adventure is to determine our ASCII characters. Here we have our ASCII characters arranged from darkest to lightest. We'll be using these to render our images. To work with images, we will not be using the Python image library, but I'm more familiar with OpenCV, so we import CV2. Then we define our image to ASCII function, which takes an image path as a string. Then we use OpenCV to read the image by doing cv2.imread and passing it the path. If the image is none, it would mean that the path is not valid, so we tell this to the user and return. Now we get the height, width, and channel of our images. Channel here means if it's a grayscale image or is it an RGB image. Basically, it's like the color dimension of the image. Then we calculate an aspect ratio, which is width divided by the height of the image. We'll need this for further calculations. Now we set a new width. We are setting a new width because we are working with the terminal and it may not be the exact same width we would want to use. I tried 100 and 150, both worked all right, but I ended up going with 100 when I was recording the video. Now we calculate a new height for the image using the width and the aspect ratio. We're doing this because ASCII images are typically wider than they are tall because of the characters we're using. Characters like @ percent, the pound symbol, those characters are kind of wide. 0.55 is the scaling constant. Now we resize the image doing cv2.resize and passing it the image. Then we convert the image to grayscale. Funny thing, OpenCV images are actually blue, green, red, not red, green, blue. So we convert from blue, green, red to gray, then store the image once again. Okay, so now we match pixel intensity values to ASCII characters. I guess I never told you what the image variable contains. Well, when we did cv2.imageRead, when we did cv2.imageRead or imread, it returned to us a matrix containing pixel value intensity score between 0 and 255. So here we just match them to the positions in the ASCII character string. Then we make the image up by the characters we have and the width we computed, which is 100. So each line you see printed out on the terminal contains approximately 100 characters, each separated by a new line. Then we just return the characters and we're done. Now we try the image. We call our function image to ASCII and pass it an image called suitable.png, then print the results to the terminal. And boom, here we have it. It looks okay, I would say. It looks okay. It clearly looks like the image. But this is basically a toy. I saw a tool that could actually turn videos into ASCII videos with colors and everything. I saw it on Twitter or X. Yeah, so that's about the end of this video. If you like the video, please leave a like, subscribe, and if you would want to see me do something more with this, maybe we could try live streaming a feed and having the feed play out as just like a bunch of ASCII characters, right? That would be cool. That would be really nice. So yeah, leave a like, comment your thoughts, and tell me if you would like to see that as another video. Thank you for your time and have a great day.